So thanks a lot for joining in and letting us present our newest version here of RoboBend. So it all started that one of the first companies that we actually were meeting with, BCM Transtech. It was one of the first companies that they showed interest in a press brake robot, and they had once said that the small version that we had is very good and is also very good for some of their pieces. But if they should buy it, they would need a robot that could work with the bigger pieces. So that became the idea that we wanted to finalize a smaller version. I'll get a little back to the 1200 and the 3000 that Thomas has mentioned in the introduction, but that they gave us the idea that we have to have two versions. We have to have a version here which can be used for bigger pieces, and then we were so lucky to be involved in a project called Trinity, which has partly helped us to develop this solution and being able to then install it by BCM Transtech as we did last week. And then the good thing about this project has been that we got BCM Transtech very, very close to us. So many big thanks to them and their inputs on the project of building this RoboBend3000. All the requirements, how it should be working, what is important. We had an idea for the smaller one that it should be very flexible, very mobile. And then they move easily away, and it should still be, but as they have said, the bigger one here is probably going to stay most of the time at our press brakes. So it's good that it's mobile, but it's also good that we simply just have space so we can get in front of the robot and then do a little of manual bending if need be. So all those things, a lot of around quality. We have also managed to work on an ankle measuring and other things. All those things has been the important inputs that has made it possible for us to build a first solution that we could install by them. It's a simplified version from the point of design. I'll share you how the design will be looking like if you are installing it in yours or your partners, your clients, places later on. So this is a simplified design version that we have here in the BCM for now. We will fully finish it a little later from design point of view, but when you are in the development, then you are also producing some of the parts. So that's why this has to come as a second step. But now, what we can show is that the functionalities are there, and then that the functionalities are actually more or less as it will be in the new standard 3000. So, but why at all to care about why to automate the bending processes? When we started a few years back, talking with companies about how to automate the bending process, we got started talking about the lack of operators. What we have seen over the last 2-3 years is that this has become a problem that most of the companies actually we are talking with is realizing that this is actually becoming a real growth killer. If we don't have operators, we can't find the good operators, then we don't have capacity in-house, and then that means that if we can find a good supplier and then pay for it, then that's a way to solve the problem. But it's more expensive, and then you have to rely on suppliers, and then at the end can they deliver? So instead of that, you have the capacity in-house. So this could be potentially a very big growth killer. We had a meeting with a new client a few weeks ago, where they told us that all their operators, they are between 55 and 75 years old, and probably the youngest ones, they are next year 56 and 2 years 57, because it's really getting difficult to find the young people that wants to stand and do this repeatable and dirty work. So this is why this is a key thing that they actually with the robot we provide the higher capacity on on existing press brakes, and then we are not killing the growth in your companies. So that's why it was a strong business case, a workful a robot at the press brakes, then we are solving a really large problem in the sheet metal industry. So the RoboBend is what we call world's first standard bending robot. And what do we mean with that? We are not claiming that we are the first ones who came up with the idea that you could put a robot in front of a press brake. Integrators, engineering houses have been already installing such kind of solutions, but you know how it is. Engineers, they cost money, and then if you have to get functionality and then the flexibility, then it's becoming a very expensive solution. So that's why we at once made it as a standard solution, which means that not the one client has to pay for all the development cost. So that means that it's a standard solution where you can come and see that it's being demonstrated. You can see how it works. You know that the same thing as you see in the demonstration place is the same thing that you're getting in your place. So you get an understanding of how it's working, and then that it's reliable, and that the price is making it attractive. So our solution can control most of the press brakes. I'll get back to what we have made of solutions to handle most of the press brakes, but we can more or less put it behind all the existing press brakes around in the world. As mentioned earlier, it's not just that we are making the bending process more efficient, they're saving money and salaries, but it's actually also that we are providing higher uptime and higher capacity on existing press brakes. So that again means if you are out and you can see, okay, I could maybe find some new operators, but they only want to work in the first shift. So if I should get more capacity, I have to buy one or two more press brakes. Then instead of doing that and hiring more people, then you can buy a robot and then they put it at the existing press brakes. It's simple to program and easy to use. So that means you don't need to be a robotic engineer in order that you're being able to handle the robot. It's quite easy to handle. Of course, you need to know something about how the press brake is working. You know, the robot is never better than the specialist that they can make it work with the press brakes. There is always some tricks that you can do on the press brake, and that you can make the robot do the same tricks as well. So it's mobile, which means it can be moved to and from the press brake, and it's a standard solution. They provide you a short payback time. As mentioned by Thomas in the beginning, we actually have two solutions. We have a RoboBend3000. So I'll not go very much into details here, but only say that the next version of the 1200 we are producing right now, and then they will be installing, and then by our partners Tool Denmark and Teknbyen, and then by Odense, where it's possible to come and see it. It's also possible to have an online demonstration if you cannot travel in. But after the summer vacation, and when we start producing the next ones, we will then also constantly have a model standing in Vilnius, where it will also be possible to book a meeting and come and see how it works. So this can handle up to items with 1200 millimeters length, and then pieces up to 10 kilograms, and then there was a 1.4 meter reach. So it was a very high repeatability, precision. I'll get back to what kind of robot arm we are using, which is the reason why it's very precise. It's mobile, so that means it actually takes, when we have done it a couple of times, it takes under 10 minutes to move the press brake, move the robot to and from the press brake. So it's, when we say mobile, we really mean that it's extremely fast. To if you want to do in the morning a little of test bends of something, you can do that and then place the robot afterwards and then get started doing it automatically the rest of the day. It's not with a gantry system. The 3000 that we'll get back to is a standard with a gantry system that can be put in the 1200 as well if you need to enlarge the reach of the robot. So, but the 3000 is what we will be focusing mainly on today, up to 3000 millimeters and 30 kilograms. And then with 1.8 meter reach and plus the gantry, the rail system that enlarges the reaching along all along the press brake. So it's a bigger robot arm, so the precision and the repeatability is slightly lower, but still very high. It's also mobile, but there you need a pallet lifter, and then it takes a little longer time than the 1200, but it is absolutely mobile. So if you want to move it away for some time, then it's possible to do that. And we will see it in action when I'm through here, and then the Domitas that is also with us, our chief technology manager, will tell when we are showing how it's working, when you will see it in real life. But just to go through some of the things that it consists of. So first of all, the links from the backside and up to the press brake is 6.5, and the width is 5 meters, and the height is 2 meters. So here you have an overview of some of the main components, which I will get back to, which is the feeder where everything starts, the main robot, the unit with the robot arm, the repositioning station, the collector zone, and then the okay, good. So yeah, but then we will get back to all the main components. But let's start with what is most important, and that is actually the user interface. So which was a built-in offline software package. So the user interface, which we have built up, is made in such a way that there can be different people with different rights on the user interface. So you can have the programmer that has rights to go in and then change programs and then put in new programs and then plan up the day's production. And then you have the operator that they will, every second, third hour, whenever it's needed, they go down and they empty, and then they put in new pieces, and then they start up the robot with the next pieces, which then takes a few minutes. So the idea is when you have an item that you have never produced before, then you have a DXF file, which is converted into a bending program using our offline program software. So that means that you have the file, and then it's being read into the software, and then you get both the press brake and then the robot programs. The robot programs, there is some fixes that you have to go in and do. It's quite standard what you have to go in and check, and where you can go in and optimize. Also, if you can see that they are suggesting that the robot is coming with, you could see that you could do it differently. Then it is possible to optimize on how to do the sequence, and which is taking for the simple ones 15 to 30 minutes, and then the very complex programs a little more. But it's not that it takes days to do. To fix a program for the next piece. So and then you get the generated simulation videos with information about the grippers and tools, and then the positionings, and then and also estimated production cycle time. So so all this you are getting, and which is laying then in your database, so that when you pick it up before you want to start producing, then you can go and check that I have the right tooling, I have the right grippers, I have the right everything before I start producing. So So this is what the user interface is used for, and then you can use it to plan up today's production, so that it's already ready. So it's not that you need to go and then put in a lot of new things every time you are starting on the next project during the day. If you have 2 or 5 or 8 different programs during the day, they are laying ready, so it's very easy to switch from one project to the next. And then what I promised you is also the explanation about why we can handle most of the press brakes. So we have made what we call a robot bending machine interface, which is a solution where we interface between the robot and the machine, which enables the robot actually to take over fully control of the machine. So all of it means that we are running the process through the robot programs, and then it's the robot that knows where the press brake is. The press brake is giving a signal when it has done something, and the robot is giving a signal to the press brake when it has to do the pressing. So the feeder and the feeder area is where you are on the pallets putting in the next batch of metal pieces that you want to produce, and then where we also have a separator that ensures that you are lifting only one piece up at a time, and with that ensuring that we are not creating any troubles by having 2 pieces suddenly. So it's only picking one piece at a time with this separator. We have the robot arm, and which is a FANOC robot arm, and then the rail gantry system, which, as mentioned, makes it possible to drive, along the press brake. So actually, you can handle the pieces where you can put them in different places in the press brake, or have the long pieces that we can handle them fully. So and then we have a little rack for the grippers. So where you then if you are producing some bigger items, and then later on you need to produce smaller items, then the robot goes down and picks up the gripper, and then does the gripper changing automatically. So I've mentioned a few times, but this is the robot arm that we are using from FANOC. FANOC is the biggest producer of robot arms in the world, from Japan. They are very strong on both on precision and repeatability. They are also having spare parts, which means that any robot they have made, they are still able to deliver spare parts. So investing into the RoboBend, the robot cell, also means that as many years as you are working with the robot, as many years you can get spare parts for the robot arm. That is the main mechanical part. There is positioning and repositioning stations. So when you are picking up the pieces, you need to be sure that you're picking placing it fully correctly into the press brake, and then the way is that we first place it in the repositioning station, and then we can pick up the piece from there. This is the fastest way to ensure that we are actually putting it in, so that we are starting the bending program with the piece laying fully correctly into the press brake. Sometimes the pieces, the robot arm we only have one arm, so that means sometimes you need to place it and then they regrip it. So there is also a regripping station where you can place the piece, and then let the robot arm pick it from another angle or side if need be, so that we can do all the bending sequences. And then there is collector zones. where we can put either in a box or we can put on pallets, and then they can be taken out, and then the empty pallets or boxes being placed in. So that means that you will use the doors, and then using the doors, getting close to the press brake, getting close to the robot arm, it will automatically stop the system. So you can never get close neither to the press brake nor to the robot arm, and it is working. So all the safety is thought through in our design and in our programs and the way that the robot is working. We have a coupling system where I place it simply to the ground, and then which means that it's stable, but it's also easy to dismount and so that you can lift it away. So it's stable, but it's still mobile. And then we hope that you like the design of it. We think it's important that it looks nice when it's standing out in the production. So so this is how it's going to look like when we are placing the next RoboBend3000, as mentioned before. It's not the way that it looks right now in BCM, but in order that before the summer vacation could show you how it's working, then we decided to make the webinar here. But this is how they are going to look like in the future. So it's both to make it look nice, but it's of course also for the reason of the safety that we have, the cover, the doors, that encapsulates the robot solution, so that it works safely at any time. So this is a short introduction, so that you get the idea of why we have done it, why it's a good business case, what it mainly consists of, and then you will get a few minutes now to see if they are working in the BCM Transtech. But if you want yourself to come in and see it, then you're very welcome to contact us, and then we can organize a demonstration for you, either online where you can see it they're working, and then you can have an individual talk with us, or if possible to come and visit us, and they would be very happy to show it to you real and in live, and then they discuss the options and how it's going to be a good business case for you. Because ending with that, the robotics for RoboBend is not about having something fancy standing out in the production. It's nice, that looks nice, and then yes, it is the new trends that we have to have robots to do some of the things. But first and most, it's important that we can explain to you, and you can explain to yourself, that this is going to be a good business case for you. It's a good investment that you're doing. This is what is important. It's not about the technology, but it's about how it helps you to make better business. This is what is important for you, to help you with. So how we can help you to understand how it can be a good case for you, please contact us. We can discuss it, we can show it live, and then you can see for yourself how it is working. So
thank you, Thomas.
That can be, yeah. So I'm ready to answer questions at a little later stage, but this is a presentation I want to do here.
Yeah, exactly. So if there are any immediate questions, please do ask them. You can either raise your hand or write in the Q&A. And I see we have one question, and this is probably more to Domantas, because it's a technical question. It's the question: do you use ROS or have ROS interface? Domantas, maybe you can help us with the technical question.
Yeah, so for now we are not using ROS, but we are looking in the future to implement the ROS system.
Good. Thank you. So maybe you'll be able to comment that through the demonstration. So now we will be switching to the demonstration. So Domantas will be joining, as he already joined, and commenting more on the technical process. So let me quickly connect and share the demonstration. Okay. Yeah. Okay. Please let me know if you can see it.
Yeah, so we can see it. So now we will start up the demonstration and cycles in the Denmark. So as you can see, the whole cell is powered up, and now the robot is going up to the feeder zone, where we have pieces of 3 meters laying in a stack, and the robot is ensuring that it's picking up one piece at a time by using sensors and beam separator. After that, we are ensuring that we are calibrating the whole part to the robot system, because there might be some inaccuracies by using a liner. And after like the piece is calibrated to the whole robot system, the robot is coming to the press brake, where we're using smart fingers to ensure that the piece is inserted in the right position every time. And after the bend is complete, you can see also, as Thomas explained, the robot is using the regrouping point to help it rotate the part around, so it can do all of the bends as human operators would do.
Domantas, there's
Yes.
a comment that your microphone is a bit low, so if you could just maybe talk a bit louder. Thank you.
Yeah, okay, so I will try to talk a bit louder. So as you can see, the robot is inserting the parts in the press brake and doing all of the necessary movement of the parts. And as we made this solution for 3 meter parts, it is actually helping a lot, even the BCM, as the robot is manipulating the part of 3 meters long, which is hard for some human operators to move around. So now for some technical side of the RoboBend itself, we have robots standing on a rail, which is 3 meters in length, which allows the robot to reach the whole cell around a bit more. So this was necessary for such size robot and for pieces which are 3 meters in size. Then we also have different sized grippers which are laying around the whole cell. So the robot has the opportunity to bend also the smaller parts, which are placed near the external axis. So even though this robot can bend pieces up to 3 meters long, you can also use this robot to bend smaller pieces. And in this way, you can use this RoboBend cell very flexibly. Also, what you can see on the screen right now is laser check system. So in this solution, we have adapted new technology which helps us to bend the pieces to the right angle every time. So we are doing the angle tracking in real time, and the press brake is adjusting itself, so we are always getting the right angles. And this is very important if you want to get the pieces right from the first bend. So actually this helps us to reduce the setup time for the whole robot system, and you can easily go from the manufacturing drawings, which are inserted as the XF, into the whole system, and have the robot programs ready for the bending of new pieces relatively fast. We also have the palletizing options for the robot and how to palletize the parts. And there are stacking solutions, so you can stack the parts one on top of each other, or stacking them one by one at a side. So there's a lot of flexibility to do this while programming the parts, and the programming itself is very user friendly, and it is based on graphical interface. So there is no need for a lot of experience in robotics, as the robot programs are generated automatically. Also, we can say that the most important step in our system is the flexibility to change from one part to the other part. So if the robot is bending one part, as you're seeing, but you want to start bending in the other part, which is using the same tooling on the press brake and the same gripper, for example, on the robot. So changing between bending one part to bending the other part is in a matter of a couple of minutes. So you just ensure that you have inserted the right pieces into the system in the feeding zone, and then you can start the new program by selecting it in our user interface, and the robot is manufacturing them in a very fast manner. And also you can prepare for new pieces even when the robot is working. So as you can see for now, the robot is working while the human operator could be preparing for new pieces and ensuring that new stack of pieces is prepared, and then in a few minutes the robot would be able to start making different kind of parts. And we have also with the ability to connect to any kind of press brake, and we are using our RBMI system to ensure that we can control the press brakes in the right manner. So thank you for our demo, and now I will be ready to answer some questions if you will have some.
Yes. Are there any technical or non-technical questions from anyone? So again, you can raise your hand and ask, you know, with your voice or type it in any case. All ways are acceptable. So there's a question from Jens. What about interface to Salvanini? How could you comment on that?
Yes, so we haven't done the installation to Salvanini, but as we have done our research, so we are just taking the steps from the press brake, which are indicating in which state the machine is, and then doing the control of the press brake itself. So it actually doesn't matter what type of press brake is, as their control is unified in the sense that they are working in the same principle. So the whole we would be able to do the interface with a Salvanini. Just answer.
So a follow-up question. So it's not a confirm. So as I understand, we have not tried it, but we're pretty confident we could do it. So
yes,
we will be able to do it.
Yeah. Yeah. So Donatas, maybe in this case you could talk more about the RBMI, how you know how it works and why, you know, because the initial tests, you could say that they were done with an old Amada press brake where only 1-0 contacts are available. So yeah, we have pretty a lot of experience in doing that. Yeah.
Yeah, so I can tell you what kind of experience we have. So we have experience with very old Amada machine, for example, which was manufactured in 1988. So, and then we have also installed the RoboBend in a bit newer press brake, which was manufactured in 1995, the Fasti company. And now we have also installed the newest version, so in Armaxen, which is controlled by DLAM. So we can say to you that if your machine is even very old, we can make the robot work with it. Maybe not all of the features are gonna be present, as newer press brake controllers are like giving more functionalities to the press brake, but we cannot add more functionalities to the press brake, as the press brake is the limiting factor, for example, here. So we have experience with from very old machines to very new machines, and we can control them in a pretty simple manner, actually.
Thanks, Domantas. Are there any more questions, technical or business? Maybe any questions on the 1200 as well, as it's a little smaller version, but
I can see a question from Q&A. Which field do you use to communicate between motor drives to motion controllers? So all of the control is done by the FANUC. So we are buying the FANUC robot and the control box for it. So we are not, and the 7th axis we are using also to use the FANUC motor, which is giving us more usability, as the robot then has the opportunity to move in all 7 axes simultaneously. So we have more range of movement, which can help us during the bending cycles, as we have more reachability.
Mm-hmm. Thank you. Any more questions on the demonstration or the technical issue questions or business questions? Okay, so I think we are done with the questions, unless some last-minute question will drop by. But thank you, Domantas, for commenting on the technical questions. And of course, we are, as Thomas mentioned before, we are always able to do an individual demonstration to each company and then show it either live in Denmark or do it online as well, as we did today. And you can ask them questions, more in depth. So if no more questions are there, so maybe Thomas, you could do a short wrap up. I will just before that, I will mention that we will have other demonstrations as well. RoboBend1200 will be demonstrated probably somewhere towards the end of the summer or beginning of September, somewhere around that. So the 1200 version will be there. And we will also have other demonstrations like the flexible solution for welding applications, welding robotics. So Thomas, maybe you can shortly wrap up, and we will finish the demonstration.
Yes, I can do that. So thanks a lot for joining in, and then for good questions that they allowed us also to deepen a little into what is your technical concerns. So again, to see it in real life is the best way to to show, and then they discuss each of the details. So this is what we very much recommend you. So we will finalize on the design and then the small changes and then BCM Transtech here right after the summer vacation, when we are getting in, when we have to also install our RoboBend1200 and then a few other installations for the first clients that we have to do here right after the summer vacation, and then as soon as it's installed by Tool Denmark, where we are having our demonstration robot standing. Then we will at the end of August be able to invite you all in and see that new version, and which is also nicely packed in. So it is going to look like we were showing on the PowerPoint. So you will see for yourself that it's not just a good robot, but it also looks nice in your factories. So we look very much forward to hear from you, hear what we have for more questions. Sometimes, you know, it's fine to ask questions here on a common demonstration, but we have already got the experience that the companies really likes to come in one by one. So that is how we organize our demonstration events. The companies are coming one by one, getting their time. We show some pieces being bent. We are discussing the individual needs, and then so that it's not just about that here is a robot, but this is the robot which is for you. So this is what is important for us. That is that we are delivering a robot that really makes sense. That is a good business case for you. So that will be my last words again. Please contact us and let's discuss how this becomes a good business case for you.
Thank you, Thomas. And thanks to all the attendees again for joining. We hope that you had a fruitful demonstration and we answered most of your questions. If not, please contact us with the contact provided, and we'll be looking forward to be speaking to you again soon. So thank you, and have a beautiful day and have a beautiful upcoming summer. See you all.